Okay, we have x is equal to 2y. For your last example problem, we have 3 of them. And so what we want to do is, these are currently in rectangular form. What we'd like to do is put them into polar form. And so what that means is we want to take the x, y values and move them to r theta. We learned a little bit about that yesterday and the substitution that we use. My question to you is, let's understand ahead of time what kind of graph it is. What is the graph of x equals 2y? What shape does it make? It does make a line because it's the same thing as y equals 1/2 x. So it has a slope of 1/2. It travels through 0. And so it's something to that nature. So let's think about in terms of a radius and theta. Look at this point right here. And then this point just a little bit further up. Does that form the same angle or a different angle with the x-axis? Same angle. In fact, does the angle ever change? No. Does the value of the radius, or how far it is from the center, does that change? Yeah. And in fact, we can have the same angle but a negative radius to get points over here, correct? So we want to, doesn't matter what r is. R could be any value. We want to find out what the theta value is that will make that line. And so what we do is we do a substitution. And you've learned this. That for x equals 2y, we can plug what in for x? R cosine of theta. And what can we plug in for y? I'm going to divide both sides by r cosine of theta to kind of combine and simplify some terms. What is r cosine over r cosine? 1. And what, so the r's cancel here. What's sine over cosine? So you get 1 is equal to 2 tangent theta. What happened to our r values? You cancel. They're gone. Does it matter what r is in this problem? No, we said that it doesn't matter, and you see that they go away. But what does matter is what theta is. So can we solve for theta? Yeah, we can. How do you solve for theta? What do you do? So 1/2 is equal to tangent of theta. And for polar coordinates, we will continue to work in radians. So tangent inverse of 1/2. And working in radians, what do you get when you tangent inverse 1/2? 0.46, right? So that means that this angle value is 0.46. So theta equal to 0.46 is the polar form of this line. Theta equal to 0.46 is the polar form of this line. You might ask, why would we ever convert something from rectangular form to polar form? Because for some of us, this seems a lot more confusing than when it started, right? Let me give you an example where it's actually simpler to have polar form instead of rectangular form. If you look at problem B, it says x squared plus y squared is equal to 25. What kind of a shape does that make? It's a circle with a radius of 5. So as we look at some points here, let's look at the blue point, let's look at the red point. Assuming I drew this correctly, both the blue point and the red point are how far from the center? 5 units. It doesn't matter where they are, they'll always be 5 units away from the center, correct? So then what we need to do is we need to consider the angle. Does the angle change for each one? Yeah. This angle is going to be between 0 and pi over 2, whereas this angle is going to be between pi over 2 and pi. So theta does change. But regardless of what theta is, r is always 5. So let's show that r is always 5. Let's justify that. We will do that by plugging in something for x. What do we plug in for x? R cosine of theta, quantity squared, plus r sine of theta, quantity squared, is equal to 25. What do we get when we square that? r squared cosine squared of theta plus anybody see a little trick I can do here? What do I do? Sine squared plus cosine squared is 1. R squared is 25, so therefore r is 5. And we said at the beginning that the radius will always be 5, okay? And that we it doesn't matter what theta is. Theta can be any value. Okay. Now, this graph, is it a function or is it not a function? It's not a function, does not pass the vertical line test. Are we able to graph things that are not functions on your calculator? We are? How? Out of here. Out of here. Yeah, if we change it to polar form. So you can't plug in, you know, x squared plus y squared equals 25 on your calculator. What you can do is take out your calculator and you can go into, first you have to reset your calculator because the smartboard is stupid. And then you go into mode, and instead of being in function, we can select polar. And we come up with an r value. We chose r to be 5. And in my window, a very different window, if we want to complete a full circle, theta has to be between 0 and 2 pi, or 6.28. You can see that right there. So if I zoom standard, we'll see what we get. Why doesn't it look like a circle? It's not zoomed squared. So we will zoom as a square, and it will adjust the viewing window, and so I have a circle. So polar form and parametric form, which we'll learn later, are very, very helpful and useful for being able to graph things like this and perform operations. And there's a lot of really neat type of entries that we can use. For example, try this one. How about we do 8 cosine of, we'll do 3 theta. You like that? It's the same spot as the X spot. Kind of cool, huh? The possibilities are really endless. You have all sorts of graphs you can generate. And we're just looking at just the very basics of it. Does that make sense? All right, let's try one last one. You ever try to graph a vertical line on your calculator? I remember when I was your age, a number of times I wanted to draw a vertical line because it was used in linear what? Linear programming. Linear programming was used, calculus was used, and I want to draw a vertical line. And it's challenging on your calculator. You got to create a slope of like, you know, 1,000,000 or something, so that looks like it's straight up and down, but it's really not. And you know, you kind of play around like that. Well, there's a much easier way to create a vertical line, and we can do it by using polar form. So let's try to anticipate ahead of time what the graph is going to be. If I pick a point, say a blue point, and a red point, the r value, or the distance from the center, are they the same or different? They're different, aren't they? Second of all, the theta value. Is the theta value, the angle that makes with the x-axis, is it the same or different? It's different. So both the r value and the theta value are different. In fact, as I change the radius as I slide it up or down, it's going to change the theta value as well, correct? So theta and r are dependent on each other. And so we're going to see that play out as we solve for this. So instead of x, what do I put in its place? R cosine of theta is equal to -2. And if we want to graph this on our calculator to ensure that we're right, we'll solve for r by dividing both sides by cosine of theta. So we get r is equal to, what is -2 over cosine of theta? Starts with an S, rhymes with ecant. -2 secant. -2 secant of theta. And, you know, you can't type that in your calculator, but that's the answer. That's the polar form. If we go into y equals and we get rid of that stuff, and we type in -2 divided by cosine, I have to do that because I don't have a secant button. And I'm just going to zoom standard. You can see that I do get a vertical line. And, so your calculator can handle that, and kind of neat. So, any questions on those? We went from rectangular form to polar form. We're not going to go from polar to rectangular. It's not really that much difficult. We just don't really have a lot of time. So we're going to move on to other things. Question. So if I wanted to use it another way, so if I wanted to make an equation for a line that was in the y equals, that was vertical, well, so I just kind of trick the calculator. Here's what I do. I go y equals m. I choose a really large m value, say like 10,000, times x plus b. And what do you want the x-intercept to be? Oh, you want it? Okay, so you want the x-intercept to be 4. So we're gonna draw a vertical line through 4. Okay, so we'll do that. We'll choose x to be 4, and y would then be 0. Correct? So 0 equals 40,000 plus b. So what is b going to be? -40,000. So when I would draw vertical lines, I used to do it like this. If I was doing it, you know, and I had to have a function. That's what I would do. So yeah, so if you go mode and you go back down to function, you'll get back into y equals. And so here you go, Eli, 10,000x minus 40,000, and you press graph, vertical line through 4. Well, so let's take off a couple zeros here. Then the line just won't be as steep, and it won't. I mean, it's not actually a vertical line, is it? Look, he's got a little crookedness in there. There we go back in, and we get rid of another one, and oh, that sucks, right? That's horrible. So yeah. Well, I wonder what's going to happen. All right, question. Well, if you have an equation that says r equals, you don't have an r equals there, do you? Yeah, so that would be your indication that you would need to go to polar. Okay? All right, so here's your assignment. It's straight, but it's not vertical. Yeah, it's just ever so slight to the side. Well, the only way you could graph a true vertical line on your calculator is to choose something other than a function mode, because a vertical line is not a function. You just try to trick your calculator. Okay? All right, so there you go. These problems are very similar to the ones you just had, and that should be it. Question. Sure, you can add on the same page. Okay, go ahead and do that. Well, got to be smarter than your calculator, right? Yes, I used to do it in my head, but I was afraid if I just stated that we would have 10,000, 40,000, that you guys would kind of wonder where I came up with those values. So thought I'd show you.